Hello M3, this is Teacher Win and welcome to another video of chemical reactions. For this video, we are going to learn about electron configuration. So, before we start, I want you to prepare your periodic table and a pencil or a pen. So in our last video, we've learned already about valence electrons. So once again, a valence electron, so these are your electrons that are located in the farther or very far orbital shell from your nucleus. So this is your nucleus. So your nucleus is surrounded by this imaginary orbital shell. So for our model here, so the red circle here is your first orbital shell. Your green circle here is your second orbital shell. And then this pink circle is your third orbital shell, by which each orbital shell has these circles here. So these are your electron shell. So in your first orbital shell, it can hold up to 2 electrons. Your second orbital shell, it can hold up to 8 electrons. In your third orbital shell, it can hold also with 8 electrons. So once again, let's have a short review only. So like for example, your beryllium. So beryllium has an atomic number of 4. So what does it mean? So if the atomic number is 4, so it means it has 4 protons and 4 electrons. So using your valence electron shell, so we are going to complete these 4 electrons. So I'll be completing first the first orbital shell. So this will be like 1, 2. So the first orbital shell is complete. So it will now go to the second orbital shell. And let's continue. This will be my third electron. And then this will be my fourth electron. So for further information about your valence electrons, so please watch again part 3 of this video. Now, for this video, so we will be talking about your electron configuration, wherein it will show the distribution of your electrons to where these electrons are found in your atoms. So we will be using letters and numbers to represent your electrons. So let's learn some of these terms as we go on with this lesson. So the first one is your orbital subshells. Orbital subshells. So basically they are just group of your orbitals. So these subshells have different types. You have your S subshell, P subshell, D subshell, and F subshell. So let's begin first with your S subshell. So your S subshell can hold up to 2 electrons. So this line here represents your orbital. So in your S subshell, the orbital can hold 2 electrons. So 1, 2. Next is your P subshell. So in your P subshell, it can hold up to 6 electrons. So in our slide here, so we can see here 3 orbitals, wherein each orbital should be singly filled first with 1 electron. So it goes like this, 1, 2, 3. So once the orbital has been filled with 1 electron, then it will go back to the previous or the beginning orbital. So 4, 5, 6. Next is your D subshell. So it can hold up to 10 electrons. So for our slide here, so we can see here 5 orbitals. So the same with your P subshell. So each orbital should be completed first with 1 electron. So 1, 2, 3, 4, 5. Once it's complete already with 1 electron, so it will go back to the first orbital here. And let's continue the counting. 6, 7, 8, 9, 10. And lastly, we have your F subshell, which can hold up to 14 electrons. So we will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, let's get your periodic table and let's locate your S subshell, your P subshell, your D subshell, and your F subshell. So your S subshell, they are located in your group 1 and group 2 elements, and also with your helium element here. Next is we have your p subshell. So they are located in your group 3, group 4, group 5, group 6, group 7, and group 8 elements, except your helium. Next, we have your d subshell. So they are located in your transition metals. Again, this d subshell here, so they can be found in your transition metals. And your f subshell, so the first one here, so they are located in your lanthanide group and your actinide group. So let's begin first with your S subshell. So in writing your S subshell, so we have to look at first your periodic table, and remember that your periodic table has your group and period. So once again, if you say about group, that means from top to bottom. So meaning group 1 is hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. If you talk about period, or shall we say your row, that means from left to right. So meaning row 1 here is your hydrogen going to helium. Row 2 here, or your period 2, that talks about your lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So your periodic table has how many periods? They have 1, 2, 3, 4, 5, 6, 7 periods. Now, let's look at how to use this electron configuration. So let's begin first with your hydrogen element. So hydrogen element has an atomic number of 1. So meaning it has also 1 proton and 1 electron. So how do we write it? So we begin by writing this way. 1s1. So your 1 here refers to your period. Okay? Your S here is your subshell. And your 1 here, it refers to the number of electrons or your number of protons. But for our video or for this configuration, we're talking about your electrons. So your 1 here represents your electrons. Okay? So using your orbital diagram, so it may look like this. So your 1s1 looks like this. Now, let's go with element helium. Your element helium has an atomic number of 2, so it means it has 2 electrons. So it will go like this. 1s2. Remember that your S subshell can hold up to 2 electrons. So for your S subshell, the maximum number of electrons it can hold, it's only 2 electrons. So in your orbital diagram, it will look like this. So 1 and then 2. Okay, now looking here in our atomic model, so your hydrogen, so your 1s1 looks like this. Your helium 1s2, it will look like this. Now let's go with your element lithium and element beryllium. So your element lithium, so it has 3 protons and 3 electrons. So how do we write its electron configuration? It will go like this. 1s2, 2s1. Okay, so remember, so using your atomic model here, so if this is like 1s1, then this is 1s2, right? If you look at your first orbital here, it's already full. So meaning it has to go to the second orbital shell. So in your second orbital shell, there will be 1 electron that will be completed here. So meaning, if you are going to use your periodic table here, so you can write it like this, or you can see it like this, the pattern like this. So this is like 1s1. So this is like 1s2. So meaning, your lithium here is already in your second period or in your second orbital shell. So this will be like 2s1. So in your model here, in your orbital diagram, so we can write it this way. So 1, 2, then 3. For your beryllium, you're going also to write it this way. 1s2, 2s2. Because this is like 1s1, 1s2, 2s1, 2s2. Okay? So also you can look at it here. So atomic number is 4. So you also have like 2 electrons here and 2 electrons here. So the total is 4. In your orbital diagram here, so we can have it this way. So 1, 2, 3, 4. Using your atomic model here. So 1, 2, 3, and 4. Now, let's look at your P subshell. So our example here is your oxygen. Remember that your group 3, group 4, group 5, group 6, group 7, and group 8, they are your P subshells. So how do we write the electron configuration for this element? So we have to continue. We don't have to jump to P subshell. So we have to complete first. So if this is your 1s1, so this will be your 1s2. Then this will be your 2s1, 2s2, 2p1, 2p2, 2p3, and 2p4. Okay? So using your orbital diagram, so it will look like this. So 1, 2, 3, 4. Then 1, 2, 3, 4. So this will be like your first orbital shell, which can hold 2 electrons. This is your second orbital shell, wherein the s subshell can hold 2 electrons. This is your p subshell, which can hold up to 4 electrons. Now, I want you to think of your electron configuration of your sulfur. You can pause this video to think of the answer. Okay, let's try to check your answers. So, your element sulfur, it is located here in your p subshell. So, in writing your electron configuration, so we can write it this way. So, if this is like your 1s1, and then this will be your 1s2. So first orbital shell is complete, so 1s2. Next, you have your 2s1 and 2s2. So your second s subshell is complete, so you can write 2s2. So this will be your 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. Okay, your second p subshell is complete, so you can write 2p6. Next, 3s1, 3s2. So your third s subshell is complete, so you can write 3s2. Next is we have your sulfur. So this will be your 3p1, 3p2, 3p3, and 3p4. So we will only stop at 3p4 because this is where your sulfur is located. So you will write it this way, 3p4. So to check the value, so you can have like 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 4, 16. So this is the complete or full electron configuration of your sulfur. Now, imagine if you're going to write a full electron configuration up to the 118 element. So if you're a scientist, it will be a very, very long full configuration, right? So therefore, let me introduce to you the so-called condensed form. Condensed form. Your condensed form is like a shortcut of your electron configuration, wherein to use your condensed form, so you have to know first what are the noble gases. Your noble gases are your group 8 elements. So noble gases. So the group 8 elements are your noble gases, or they are the most stable gases. So we have your helium, neon, argon, krypton, xenon, radon, and oganesson. So in your condensed form, so you have to look at first what is the previous noble gas before that element. So this is your sulfur, right? So what is the previous noble gases or noble gas before sulfur? So your sulfur is in your third period, so you have to go back to the second period, right? So the noble gas of your second period is your neon. So therefore, you can write your neon here. And what's the next one? So you have to complete here until to the element sulfur. So you'll just simply copy 3s2, 3p4. So actually, your 1s2, 2s2, 2p6. This is your electron configuration of your neon. So they just make it shortcut, and then you continue to the third subshell or the third orbital shell here for your sulfur. Okay, let's go now to your D subshell. So your D subshell is a bit special because they are located in your transition metal. So let's try to look at our transition metal Fe, which is your iron. So this is the location of your iron. So let's try to know the electron configuration for this element. So this will look like this. So this will be your 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d1, 3d2, 3d3, 3d4, 3d5, 3d6. Now, for your D subshell, if you look at it here, why it's not 4d6, right? Why it's 3d6? So for your D subshell, it is always one less than the row it is in. So meaning, if you are in row 4 or period 4, so it is always one less than the row. So meaning it's 4 minus 1. So you will write 3, not 4. So how do we write the condensed form for your electron configuration of iron? So you can write it this way. Ar is argon. So remember, so you have to look at the previous noble gas before this element. So we are now in period 4. So you have to look at the noble gas of your period 3, which is your argon. So actually, so this is your electron configuration of your argon. So this whole thing here, this is your electron configuration of your argon. So continue what is missing until you complete the required electrons. So you'll have your 4s2, 3d6. So again, this is your condensed form. And this is your full form. Now, let's try to look at another example. So actually, you can pause this video to think of your electron configuration for your cadmium. Okay, let's reveal the answer. So for your cadmium, you will have your electron configuration this way. So you have your 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10 because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 4p6. Then 5s2. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So cadmium is here. So that's why it's 4d10. So please remember again, this is a D subshell. It is always one row less. So we are at the fifth period, so 5 minus 1, you will write 4. And its condensed form. So what is the noble gas before cadmium? It's krypton. So you will write Kr 5s2 4d10. So this whole thing here, this is your electron configuration of your krypton. And finally, your F subshell. So we will have your ytterbium, element number 70. So it's here as our example for your full electron configuration. So remember that your F subshell, it is always 2 less than its rho. So let me show you the example. So this is the electron configuration of your ytterbium. So you have your 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, then 6s2, and remember, in here, this is the continuation here. Okay, so meaning, if this is row number 6, so your F subshell is 2 less than the row it is in. So if this one is row 6 minus 2, so we will write 4. 6 minus 2, that's 4. Then you continue until you reach your ytterbium here. So F1, F2, F3, F4, F5, F6, F7, F8, F9, F10, F11, F12, F13, F14. And how do we write its condensed form? So you can write it this way. Xe is your xenon. So your ytterbium is located in this period, right? So the noble gas before ytterbium is your xenon. That's why we write it this way, Xe. Then you continue until you reach your element. So 6s2 for F14. Now, another way of writing your electron configuration if you don't have your periodic table, so you can use this format. So in the first column, all of them are your S. Okay? Your second column, all of them are in P, D, and then your F. We know already that the S subshell can hold 2 electrons. Your P subshell can hold up to 6 electrons. Your D subshell can hold up to 10 electrons. Your F subshell can hold up to 14 electrons. So using this format, you can write simply this way. So like for example, so your element lithium, right? So your lithium has an atomic number of 3. So you can simply like this, right? So we begin with 1s2, right? And 2s1. So basically you just have to follow the line. So another example, like for example, your neon, right? So your neon has an atomic number of 10. So using this one, so you can have your 1s2, 2s2. Then from here, what's the next after 2s2? So you have to go to 2p6 because your p subshell can hold up to 6 electrons. So you have your 2 plus 2, 4 plus 6, so 10. So this is the end. So like for example, another example, we have your aluminium. So your aluminium has an atomic number of 13. So how do we write the electron configuration? So you have your 1s2, 2s2, 2p6. So 2 plus 2, 4 plus 6, 10. So we still need 3 electrons. So after 2, we have your 3s. So S subshell can hold up to 2. So we need one more. So what is the next after 3s? So we have your 3p. So you have your 3p. How many electrons do we need? So we need more, 1. So this is the electron configuration for your aluminum. So you can pause this video to look at our examples of your full electron configuration and using this summary. So again, you have two options. You can use your periodic table to do your electron configuration, or you can use this summary. But M3, I encourage you to use your periodic table because not all the time you have to write this way. So please answer the worksheet and don't forget to upload a file in your Google Classroom. This is the end of our lesson for this video. So thank you again for watching and have a nice day. Goodbye.